Assalamualaikum warahmatullahi wabarakatuh. My name is HARAMAIN bin HARMAN from the Faculty of Built Environment in UiTM Perlis. I'm honored to present my research project for grade 2025 titled Investigation of Systematic Adjustment Solutions for Common Boundaries Discrepancies in Cadastra Record. Okay. This study addressed an issue that may seem technical at first, but directly affect landowners, developers, and national land policy enforcement in Malaysia. That is boundary discrepancies in our cadastral systems. Let's begin why this matter. Cadastral records are the backbone of the land ownerships. They define property lines, help determine ownerships, and support everything from urban developments to agricultural zoning. But what happens when two certified plans show slightly different boundary position for the same piece of lands? Okay. These inconsistencies can occur due to a few reasons, which is, number one, older survey methods use different datums or measurements principles. Second is lack of standardizations between neighboring lots. And the third one is surveying equipments and technology improved after the data was recorded. Let me give a quick example. Imagine a landowner wants to build a fence. He uses a recent GPS-based survey, but his neighbor relies on a 30 years old plan using a compass and bearings. Their boundaries that do not align, leading to a legal conflict. Okay, these discrepancies tough as small on a paper. Just a few centimeters and meters can cause land disputes, project delays, and complication in title registrations. Even with advancements like eCadastra and the National Digital Cadastral Database (NDCDB), these legacy issues still surface, especially in semi-urban or rural areas. That's where my study stepped in to test how we can correct these discrepancies using modern adjustment techniques. Okay. The objective of this research very focused on to evaluate and compare the reliability of two key survey methods, which is direct and indirect method in correcting common boundary discrepancies in certified plans. Specifically, we want to know which method provides more consistent and accurate results. Second, can this method trusted enough to update and correct the cadastral data? And the third is, which method is better suited for implementations by agency like JUPEMS? Okay, let's go deeper into how we carry out this study. Okay, I have selected certified plans from Alor-Redis, Perlis, which is ideal because area contains a mix of historical and modern survey data. This reflects a real-world challenge in reconciling old and new survey methods. I use two professional software tools, which is number one, standard. This applies a least square adjustment, which is mathematical process that minimize overall errors in survey networks. The second one is Trimble Business Centers, as known as TBC, is a versatile geometrics platform used by professionals for processing field data and running generated networks analysis. We created several networks combinations using both direct method and indirect methods. This combination was also tested in first-class configuration, which represent high accuracy and tight control, and second-class configurations that show the lower precision and simulating an older data. This idea was simulate a real cadastre adjustment scenario, where data from different time periods and survey quality is blended. All configurations were then analyzed using standard deviations, chi-square test, and error ellipse, also the factor analysis. This allows us to evaluate how well each method performs in preserving positional accuracy, particularly in the northing and easting directions. Okay, now let's talk about what the data show us. The angle best, which is direct method, consistently produce lower standard deviation values, greater consistency in coordinate positioning, and better accuracy in both high and quality network combinations. Statistically, these methods stay well within the acceptable confidence limits, meaning it's not only accurate but reliable and predictable. On the other hand, the bearing best, which is indirect method, show a greater variability positioning, occasional strength in second-class data, but less consistency overall. In other words, angle-based observations, direct methods, are more stable across different conditions, making them more appropriate for using a real cadastral adjustment, especially when the data comes from mixed survey histories like we often see in Malaysia. This confirms that angle-based adjustment is not just a mathematical preference, it's a practical solution. So, what makes this research novel? First, it goes beyond theory. It uses actual certified plan in known as region algorithms, giving the study real-world relevance. Second is, it directly compares two widely used observation configurations under modern adjustment tools, something not often explored by side in Malaysian context. The third is, it shows how this result can be replicated in other districts with legacy cadastral issues, offering a repeatable model. Many studies stop at identifying discrepancies. This one goes step further and process a tested software-supported adjustment solution. Now, let's talk about a real-world applications and commercialization, particularly for JUPEM. JUPEM is responsible for updating, maintaining, verifying cadastral records across the Malaysia. Here's how research can benefit JUPEM. The first one is for technical workflow integrations. This adjustment method can be incorporated into JUPEM field survey workflow, especially when dealing boundary disputes. Second is software training and modules. The standard and TBC configurations used in this study can be turned into JUPEM certified training module for new surveyors. The third is automated adjustment toolkits. With further development, a semi-automated plugin could be built into an eCadastre to detect boundary discrepancies, recommend the best adjustment method, and perform a basic least square adjustment. Next is consultancy and listening. This approach can also be packaged for consultancy services or tendered projects involving digital cadastral upgrades, particularly in rural or legacy dataset zones. The key commercial takeaway, this research offers practical, scalable, and agency-friendly tools for resolving a long-standing challenge in Malaysian cadastral system. To summarize, cadastral discrepancies still exist in affect landowners, developers, and legal process. We tested two widely used observation methods and found that direct method, which is angle-based adjustment, are more accurate and stable. The study novelty lies in its real data approach and side-by-side comparison of method. Most importantly, it has direct application potential for UPEM and other land authorities through integration, training, and automation. That's all for me. Thank you very much for your attention. I hope this presentation has shown you not just the technical depth, but also practical value of modernizing our approach to boundary adjustment in Malaysia.